Greetings, I am Musa Kumete, an electrical engineering student at the Central University of Technology in the Free State. Behind me is my poster for my project. The name of my project is an Intelligent Shopping Trolley. The inspiration behind my project comes from the fact that I've noticed elderly people and those that are physically challenged struggle with their shopping. My project aims to solve that problem. Let's start with my problem statement. It reads as follows. Shopping is a need for all. Although anyone can shop, but it is still a challenge for certain individuals, especially old people and those who are physically challenged, to use manual shopping trolleys, since they are required to push them for the entire course of shopping. The aim of my project is to improve the shopping experience of the old people and those that are physically challenged. As described by the photo below, you can see an elderly lady is pushing a trolley manually. And as you can see, it can be taxing and exhausting to the elderly lady. Methods. I had to concoct different methods so that I can come up with a final project. I had to draft a proposal and gather appropriate components. I had to draft or design 3 types of diagrams: the block diagram, the circuit diagram, and the PCB. From these diagrams, along with the proposal, I was able to breadboard my project. From there, I was able to also design the flowchart of my project, which helped me to understand the flow of my code. From there, we were able to construct the final physical project. Let's start with our block diagram. Because this project was was taken from an existing project, I added new components to the old project, and these new components are circled in red. On my block diagram, I have the motherboard, which is the Arduino Uno R3, which is powered by a USB 5 volts. And then I had 3 different types of sensors: the proximity sensor, the ultrasonic sensor, and the infrared speed sensor. Other components for the project, which are also connected to the Arduino, were my servo motor, my relay module, which was powering the motor wheels using an external power supply of 12 volts. I also have the LCD display, which was displaying the data, the Wi-Fi, which was transmitting the data to my cloud connection called ThinkSpeak. I had to also come up with my schematic to get the exact and components and types of components which are appropriate for my project to avoid problems such as delay and other related problems. From all these diagrams, I was able to design a flow diagram for my code. I started with initialization of my motherboard, which then triggers the proximity sensor to start or to continue with the process. The proximity sensor is the one which was measuring the optimum distance of the person behind the trolley. Once the person is at the optimum distance, the trolley begins moving. If the trolley begins moving, the relay will power the wheels so that the trolley continues moving by causing the wheels to continue turning. On my wheels, I also had the infrared speed sensor, which was measuring the speed of the trolley. And on the front of my trolley, I have the ultrasonic sensor. From then, I have the LCD display, which was displaying the data, the Wi-Fi, which was transmitting the data to my cloud connection, and then everything was ending up at the cloud connection ThinkSpeak, where the data is stored and analyzed. Then we end the process. At the end, I have the construction, the final physical project for my project, and then I will demonstrate how everything is working, and then I will also show how the data is stored on ThinkSpeak. This is my physical project. Now I'm going to demonstrate how it functions. As the aim was suggested at the beginning, the aim is that all individuals and those that are physical challenged can use this trolley with ease. Now I'm going to plug the power to supply my project. Since now it has power, all the sensors and all the components of the trolley has been activated. I will start with the first sensor in front of my trolley. This is a very important sensor. It's called ultrasonic sensor, and it detects the obstructions or the obstacles in front of the trolley. It will face on the right, it will face in the middle, it will also check on the left, and then on the LCD it will display the distances of the obstacles, or where the obstacles are, and then the user will have to decide based on that information which direction is best for him or her. Now we're gonna start moving. So to move my trolley, I have to be at an optimum distance to my proximity sensor. I don't have to touch the trolley. You don't have to do any work done on the trolley. It will manually move on its own. How does it move? As I will stand on them, I will be at the optimum distance with the proximity sensor. It will trigger the relay, and the relay will trigger the motors of the wheels, and the wheels will start turning. Optimum distance, and then the trolley begins moving. So one thing that is very important, the user of the trolley has to maintain the optimum distance with the proximity sensor, or the predetermined distance. Once the user moves away from the trolley has to stop. Imagine someone is buying in the shop and they are going to pick something which is further away from their trolley. The trolley will suddenly stop and wait for the user to come back to the optimum distance, or the predetermined distance to the proximity sensor. We're going to demonstrate again, and then we have to note that the LCD will also display more information as well as the trolley is moving. Optimum distance, and the trolley begins moving. The trolley begins moving, stops. If I go back to optimum distance, one thing I have to note now, so I'm closer to the wall, the LCD will display the shortest distance in three of the distances that is displayed on the LCD. This means I'm closer to the wall. As a user now, I have to make a decision to move away or to choose another direction, because now there is an obstruction. One important thing, below the wheels I also have the infrared speed sensor. If you notice at the beginning, when I start, when I plug in, it will show the number of steps and RPS taken by the trolley. This information is very important because it will tell us how much the trolley has been used over the day, and what speed has been used at. Thank you. This is my cloud connection. This is the data represented by or transmitted by the Wi-Fi module to our cloud connection called ThinkSpeak. This is the name of my channel, as my project, which is called Intelligent Shopping Trolley. So on my trolley, I had the ultrasonic sensor, and the ultrasonic sensor was measuring the distance from the obstacles. So there is the distance from the obstacles as the user is continuing using the trolley. And then secondly, I have the speed, which comes from the infrared speed sensor, which is measuring the speed of the wheels. It is then represented there according to this chart. And then third, I also have steps, which also come from the infrared speed sensor. These ones are very important. The steps are very important because when we are doing our analysis, we'll be able to determine which trolley has been used the most, because it will have the highest number of steps compared to other trolleys being used there. And then we have this very important one. This one is from the proximity sensor. It shows the occupation of the trolley, or the usage of the trolley. So whenever the trolley, whenever the chart shows 1, it means the trolley is being occupied. Whenever the chart shows 0, it means the trolley is not being used. So you can determine how a trolley was used across the day. Thank you.